Hello everyone. So chapter 4, section 6 in our geometry book deals with slope. So what is slope? And slope deals with lines. Here's just a couple examples of how we might see slope. So obviously we're going to be looking at lines. And overall we're referring to the steepness of a line, which we calculate by finding the rise over run, or otherwise known as change of y divided by change in x, or the technical math version, slope of a non-vertical line, segment, or array containing x1, y1, and x2, y2 is defined by the following formula. Or we see the triangle y, triangle x, which is really just kind of mathematically called delta y or delta x, or as we see up on the side here, that little triangle also means change, so change of y over change in x. So really all you have to do is make sure that since we are subtracting, unlike the midpoint where we are adding, your order is going to matter. 3 minus 2 is not the same thing as 2 minus 1, so you just have to be really careful. So let us find the slope of each of these. So I see, well, first let's make sure that we identify our x values and our y values, because as silly as that seems, some of you will kind of mix them up, and that'll kind of ruin things for you. So I'm going to decide which direction I'm going to go, either left to right or right to left, just to make sure that my x's correspond. So I think maybe I'll go to the left. So I'll do change of y over change of x. So our y values do have to go first. So 5 minus 3 divided by 6 minus negative 2. Now, 5 minus 3 is 2. 6 minus negative 2 plus positive, that is 8. And we always want to simplify, so that is 1/4. Now, occasionally you'll see in your textbook like a slope of maybe a mixed number, like maybe 1.5 or 2 3/4 or something to that effect. To make it easier on yourself, just change it to an improper fraction. That'll actually mean something for the rise over run. Let's look at this next one. Now we have a line. In a line, the slope between all the points is consistent, so we can just really pick any 2 points that we might find easiest. So I'm going to use 0, 0, and negative 1, 2. I could have used any other 2 points. I just figured, well, 0, 0 is usually typically easy to work with. So again, I'm just going to go to the left. So I'm going to identify my y's and identify my x's. And again, it's that change of y over change in x. So 0 minus 2 all over 0 minus negative 1. So 0 minus 2 is negative 2. And 0 minus negative 1 is 1. So we have a slope of negative 2 over 1 or negative 2. It is important to note that, if we have a whole number, just think of it as over 1, because that's really all it is. We go up 2 over 1, up 2 over 1. Just like here, we went up 1 over 4 to get to our next point on our line. Now, we noticed that here we had 1 was positive, 1 was negative. So there's actually 4 different types of slopes. There is zero slope, negative slope, no slope or undefined slope, and positive slope. From our previous example, we saw that the positive slope resembled something like number 1. Our negative slope resembled something like number 2. So we are falling from left to right with our negative slope, rising from left to right in our positive slope. Think of positive and negative slope, if that was your money amount. How would you feel? If your money was rising as time continued, you'd probably be pretty happy. If your money was falling as time continued, you probably wouldn't be too happy. You'd probably feel pretty negative about that. Now, zero slope and undefined slope. Well, since we're talking about change of y over change of x, Undefined is going to be where our x values do not change, and that occurs in a situation like number 4. No matter where I go on this line, my x is still 3. So that's my undefined or no slope. Really, either or is fine. You just might see one or another. And for our 0 slope, we see that would be 0 divided by any number is 0. So this is going to be our 0 slope, situation number 3. No matter where I go on this line, my y value is negative 3, so I have no change in my y value, therefore I have a 0 slope. Now, a couple theorems. Two non-vertical lines are parallel, then their slopes are equal, and if the slopes of two non-vertical lines are equal, then the lines are parallel. So this theorem kind of goes both ways. If our slopes are equal, then our lines are parallel, and if our lines are parallel, our slopes are equal. So depending on the situation you're given, you might use one versus the other. And then perpendicular lines, on the other hand, we have two lines are perpendicular, and neither is vertical. Each line's slope is the other's opposite reciprocal. So we are flipping the numerator and denominator and changing the sign. And just like the other one, if the slopes are opposite reciprocals, we are perpendicular. So if we see that we change the sign and flip the numerator and denominator, we are indeed perpendicular. So let's look at a couple of examples where we might use this. We want to show that CEF is a right triangle. Now to do this, we've got to find the slope of each side and then determine which side is the right angle if it is indeed a right triangle. So let's find the slope of EF first. Point E is at 8, 4, and point F is at 4, 7. So I'll choose a direction. I think I'm going to go right this time. So we have change of y over change of x. So we have 4 minus 7 over 8 minus 4. 4 minus 7 is negative 3. 8 minus 4 is 4. So that's my slope of EF. Next, I'm going to find the slope of, EC. Obviously, your order for these does not matter. It's just a matter of making sure you get all of your bases covered. So I've got my points. I'll determine which direction I'm going to go. I'm going to go right again. So I'm going to do 4 minus 3 over 8 minus 1. 4 minus 3 is 1. 8 minus 1 is 7. So my slope of EC is 1, 7. And lastly, I have CF. This time, just because I see, my larger numbers on the right, I'm going to go to the left for my calculations. So I have 7 minus 3 over 4 minus 1. 7 minus 3 is 4 over 4 minus 1 is 3. Now, I found the slope of each side. Which angle is the right angle? So I'm looking for which lines are perpendicular, which lines have a slope that is opposite reciprocal of the other. Well, 1/7 is kind of the oddball in there. And if I look at these two, 4/3 and negative 3/4, both there's a change in the sign, and our numerator and denominator have changed. So my right angle is angle F. This is the angle that's formed by EF and CF, which in this case is angle F. Here's another situation I might propose to you. AB has a slope of 5/2. If A is 2, 7 and B is 12k, what is the value of k? So kind of working backwards. So we know that we have 5/2 equals And I see that 5 over 2 are both positive, so though I could worry about the negatives, I'm going to make sure that when I subtract, I'm going to keep my numbers positive, so that'll help me determine the order. And my x values, my 12 and my 2, in order to keep it a positive, I'm going to go in this direction. So 12 minus 2 and a minus 7. Now, 12 minus 2, I know, is 10, and then I still have that k minus 7. Somehow this equals 5 over 2. So I can do this a couple different ways. I can solve a proportion, or I can see, well, what did I do to get from 2 to 10? And then that'll help me figure out my difference that I'm looking for in my numerator. So I'm just going to go off that route. I know that to get from 2 to 10, I have to multiply by 5. So I know my difference for my numerator, I'll also have to multiply by 5. So k minus 7 needs to be 25. So I add 7 to both sides. K must be 32. And I can always check that. So I have 2, 7, 12, 32. Let's make sure I get that 5 over 2, because if you have extra time and when you're taking a quiz or test, it's always good to know whether or not you have the right answer. So let us take 32 minus 7 and 12 minus 2. So 32 minus 7 is 25 all over 10. I know that 5 goes into both of those. So I have 5 over 2. So my k value is 32. And last example we'll go through together here. We have our p, t, and v collinear if p equals negative 2, 3, t equals 4, 6, and v equals 8, 8. Hint, to be collinear, all 3 pairs of points must have the same slope. So go ahead, find your 3 slopes, pause. I will also pause, I'll work through my slopes, and then we can compare. So hopefully you agree with me that this between each of these points is 1/2. Now even though in this step they were all different, but in the end, all of them were 1/2. Therefore, since all 3 points have the same slope, yes, P, T, and V are collinear. If at any point I saw, once I simplified my slope, they were different, I could stop right there. If 2 of the slopes aren't the same, then I know all 3 of them, there's no way that they're going to be the same. So I can just stop there, save myself some time, and say no. That's it for now. Thanks for watching, and I'll see you in class.